It's nice to get one that has some decent shoulder pads on it. It's supposed to be all wrapped up.
The older you get, the harder it is.
Oh yeah! Okay. You want to get one that's comfortable, and that this is there's no herbicide, it's just water. Typically, most of them come with a standard like a fan jet, okay, like this. And there's also ones that have a cone jet. You're just doing individual plants. But if you're planting, walking down strips and stuff like that, you would want something like this. And you keep maintaining the pressure by just keeping a pump, and you can walk along, and you can cover a lot of area in a relatively short period of time. These things hold 3, maybe 4 gallons. 4 gallons, it gets kind of heavy. So the question becomes, how do you calibrate this thing? Because, if you want to put a certain amount of herbicide, we talked about how, that's so important to calibrate something with that right amount that you need. And that's where it gets a little different. It's tricky because there's a lot of different calculations. What kind of information do you think you need to know? Okay. Well, you want to know how fast this is treating a certain area, right? It's based on putting down a certain amount of chemical on a certain area. So you need to know, how much material is coming out of here, what's the width of the fan, how fast you're traveling, and there's a lot of ways to do that. But Penn State came up with a fairly simple way. Well, not Penn State. It's a really good example. Explains it. Basically, if you look in the third paragraph, it says the calibrating a backpack sprayer. The process can be simplified by using the ounces to gallon method. And with this method, the amount of spray measured in ounces converts directly to gallons per acre. And it's based on making your calibration area 1/128th of an acre, which turns out to be 340 square feet. So what we do is we walk an area, using the appropriate width, and see how much material is going to take to treat 340 square feet. And we can lay that in different ways. We could make it a square, we could make it, in this case we made 2 long lines, basically because we have roads here, it's easier. And we're going to, we time how long it takes to cover that area, and then we cover, see how much material actually comes out, and through just a few simple calculations, we can calculate, how much herbicide that we have to put in to treat an area based on the walking speed that we're using and the output of the sprayer. That sounds reasonable, right? But it can get really complicated. So the nice thing about this is if you look at, there's a worksheet, a brown piece of paper, and again, it's based on this idea of directly 340 square feet is 1/128th of an acre. So that's how many ounces are in a gallon. It goes directly from ounces to gallon. And you can figure that out in your head, just take my word for it. Okay? So we want to figure out what the bandwidth is of the sprayer that we're using, and since some people are taller than others, we want to make sure there's maybe a little tiny bit of overlap. The second piece of information we need is to spray how long it takes for us to walk, using the same speed we would use when we were in the field, right? You don't want to be, cutting along, you want to go slow enough that you're going to actually get enough material on the ground. So you just be kind of like, something like this, like you would walk if you're out in the field somewhere. And that's going to give us how many seconds that it actually takes to cover that 340 square feet. Right? And then we measure the ounces that took to treat that calibration area. The way we do that is that after we're done with that, we just bring the sprayer back, and for those number of seconds, we spray it into a container, and we measure how many ounces came out in that period of time. All pretty simple so far, right? And then finally, we have to determine the herbicide mix. And this one, it gets a little bit, you have to go on the label and see exactly how much is recommended per label, per acre and stuff like that. But it's a relatively simple thing to figure out. And from that, you can determine exactly how much herbicide you have to add per gallon of material. And so,
why ready-to-use chemicals are outstanding for homeowners. They took the guesswork out.
But for some things, those aren't available.
Yeah, exactly. And cost-effective, ready-to-use, because they're ready to use, they're more expensive. expensive. Whereas if you can get the same chemical that is in the ready-to-use formulation and mix it yourself, you're going to save money. You know, that's really helpful for things, especially this method with stiltgrass. You're doing a defined area and you're doing a defined speed. You know, you're not necessarily just spot spraying here and there. Sometimes when you get into the shrubs or a mile a minute, you're just doing spot treatment. But the Penn State handout, and I believe even Jonathan's clip notes of it, talk about both spot spraying and doing a flat strip spraying method.
Right. So just kind of typically hose it about 18 to 24 inches off the ground.
How am I pumping this?
It pumps up and down. It's already fluid. Yeah, so let's spread it there. Just pull the handle. Okay, so like let's walk along a little bit. Just hold it at the same height. Okay, like you're going to be walking along for 3 feet. Okay, that's typical. Most of the widths on these can be about 3 to 3.5 feet. How many gallons per acre? 34.
So it's
Two
like
divided.
0.2. It's like 20%.
You do it by it's a thing by the gallon actually.
Oh, you want it per gallon?
Per gallon.
Oh, we could do it per gallon.
That's why we want the
So
ounces of herbicide per acre.
So it's 1/17 of a gallon, so it's